ladies and gentlemen. Notes 6.5 are on page 7, and they are on the surface area and volume of spheres. And we talked about how to get these formulas. So remember, again, the surface area is 4 pi r squared, and then the volume, sorry, I wrote V, but it should be surface area, and then the volume of a sphere is 4/3 pi r cubed. Okay, so question number 1 says, the dimensions of an adult human eyeball are reasonably constant, varying only by 1 millimeter or 2. The average diameter, so that's key information, is about 2.8 centimeters. Calculate the surface area of the human eyeball to the nearest square centimeter. So if I want to find the surface area, I'm going to write down the formula for surface area, which is 4 pi r squared. But it only tells me the diameter, and since the diameter is 2.8, that means that the radius is 2.8 divided by 2, or 1.4. Okay, so that means that the surface area is 4 pi times 1.4 raised to the power of 2, or 1.4 squared. So again, I'm going to figure out right here, 1.4 squared is 1.96, and then I'm going to multiply that by 4. Remember, I'm going to leave the pi alone for right now, and I get 7.84. So that means that the surface area is 7.84 pi. And remember, again, this is our exact answer. But we want to know what it is to the nearest square centimeter. Also, we generally don't say my eyeball has a surface area of 7.84 pi. We want to know exactly what it is in centimeters. So I'm going to take 7.84, multiply it by pi, and I end up getting 24.6300, so on and so forth. It says round to the nearest square centimeter, so the nearest whole number, so it's going to be about 25. So my surface area here is about 25 centimeters squared. Okay? All right. In number 2, we want to determine the radius to the nearest tenth of a centimeter of a baseball that has a surface area of 215 centimeters squared. So if our surface area, the formula is 4 pi r squared, my goal is to solve for r. So what I'm going to do is divide both sides by 4 pi. So then I end up getting that the surface area over 4 pi is equal to r squared. Well, to get rid of squaring something, I'm going to square root both sides. So I'm going to take the square root of both sides, which means that r is equal to the square root of the surface area over 4 pi. So I'm going to plug that in, that information in. So I know the surface area is 215, and then I'm going to divide that by 4 pi, and then I'm going to square root. So let's go ahead and calculate this. I'm going to take 215, divide that by, in brackets, 4 times pi, close my brackets, press enter, and then I'm going to square root, and I should end up getting that my answer is about 4.1. So the radius here is equal to about 4.1 centimeters. And if I want to do a check, I'm going to do 4 pi times 4.1 squared. Okay. So I'm going to type in 4 times pi times 4.1 squared, and I end up getting 211 square centimeters. And the answer should be 215, so I'm a little bit off, but it's good. It's just because, again, like we talked about in our last video, it's because of the rounding. But I do want to show you if I were to take the actual answer that I got here and plug that in. So remember, to get this value here, we took 215, we divided it by 4 times pi in brackets, and then we square rooted it, and we got this answer. So instead of 4.1, I'm going to use this full value right here. I'm going to square it, multiply it by 4, and then times pi, and I get exactly 215. And that's why I don't want you to round your answers until the final answer, because the more you round, the more likely your answer is going to be inaccurate. Okay? All right, question number 3. A spherical gemstone fits inside a plastic cube with edges of 10 centimeters. So if I have a cube right here, and it has edges of 10 centimeters. So this is my cube, okay? And we have a spherical gemstone inside of here. So our gemstone is going to be inside of here like that, okay? And it fits exactly inside of it. So calculate the volume of the gemstone. Well, to find the volume of a sphere, we would do 4/3 pi r cubed. And here, if you guys notice right here, we know that the edges of my cube are 10 centimeters, and I need the radius of my sphere, and that should be half of the edge of our cube because the diameter is 10, so the radius has to be 5. So in order to figure this out, I would just do 4/3 times pi times 5 cubed. Okay, so then I end up getting 4/3, V equals 4/3 times pi times 5 cubed, which means 5 times 5 times 5, which is 125. Okay, so that means I'm going to just calculate my volume altogether. So I'm going to say 4/3 times pi times 125, and I get about 523.6 cubic centimeters. So that's what we'll write down, 523.6 cubic centimeters. That's the volume of our spherical gemstone. But then it says how much empty space is there, right? So how much space is going to be left over that isn't occupied by the spherical gemstone. So pretty much I want to know how much extra space there's going to be inside of here. And in order to figure that out, I need to find the volume of the actual cube. So now in order to be able to figure this out, I need to find the volume of the cube and subtract the volume of the gemstone from it to find the volume of empty space. Okay, so to find the volume of the cube, I know that the volume of any cube is always going to be length times width times height, or 10 times 10 times 10, because all the sides are the same. So I'm going to do 10 cubed, which is 1,000. So I'm going to say that the volume is 1,000 minus the volume of the gemstone, which is 523.6. And then when I subtract them, minus 523.6, I end up getting 476.4. So cubic centimeters. So we're going to say, therefore, there is 476.4 cubic centimeters of empty space in the box. Okay? All right, awesome. And then question number 4 is a question that I would like to take up with you guys as a class. So we are done with our video for today. All right, I hope you guys have a great day. Bye.